Picture this: North Atlantic, winter 1000 CE. You're standing on a Viking longship as a wave the size of a 3-story building crashes over the bow. Seawater just above freezing drenches you completely. The wind screams at 40 knots. Your beard freezes solid. Your breath crystallizes instantly. You look around for shelter. There is none. No cabin, no walls, just open sky and killing cold. You've been at sea for 3 weeks. You'll be at sea for 3 more. And here's what should terrify you most. There's no fire. Not a single flame anywhere on this ship. No brazier. No way to warm your hands or heat your food. Modern survival experts say you'd die of hypothermia in about 4 hours. So how did Vikings survive? The answer will shatter everything you think you know about Viking technology. And I can prove it using 8 major archaeological excavations and ships pulled from the ocean floor after 1,000 years. In the 1960s, archaeologists discovered 5 Viking ships at the bottom of Roskilde Fjord in Denmark, nearly complete vessels that had actually sailed and fought across the North Sea. The Viking Ship Museum team spent years documenting everything: water barrels with residue still inside, tool chests, ballast stones, traces of preserved food, personal belongings. They cataloged thousands of artifacts across 5 vessels: warships, cargo ships, fishing boats. Not one single heating device. No brazier, no hearth, nothing. Maybe it's just these ships, they thought. So they examined other discoveries. The Oseberg ship from 834 CE contained elaborate cooking vessels, but forensic analysis showed these burial goods had never been used at sea. The Gugstad ship from 890 CE featured sophisticated water storage, but 0 cooking facilities. Fast forward to 2020, modern archaeologists using ground-penetrating radar discovered another ship at Gillestad, Norway. Technology that can detect metal objects the size of a coin. No heating systems, nothing. 8 major excavations, dozens of ships. The pattern is undeniable. Vikings did not heat their ships. But here's the twist. This wasn't because they didn't know how. Vikings were masters of fire on land. Archaeological digs at Borg in the Lofoten Islands reveal long houses with brilliant central hearth designs that understood airflow patterns centuries ahead of their time. Their cooking technology was sophisticated: riveted iron pots with integrated tripod systems, soapstone vessels with superior thermal properties. They had the capability, so why not use it at sea? Because a Viking longship is essentially a giant open canoe. Clinker-built construction with overlapping planks sealed with tar, gaps stuffed with animal hair, rigging waterproofed with pine pitch. The sail is woven wool treated with animal fat, basically a massive torch. Every surface is flammable, and there are no bulkheads, no fire breaks, no way to contain a blaze. Maritime archaeology studies show that a fire in these conditions could consume an entire Viking ship in under 4 minutes. You're 2 weeks from land. A spark lands wrong. 4 minutes until your ship is ash and you're in water that kills in 10 minutes. Vikings made a calculated engineering choice. No fire. Ever. But that creates an impossible problem. The North Atlantic in winter has water temperatures between 32 and 40 degrees Fahrenheit. Modern survival guidelines say you develop hypothermia within 2 hours and risk death within 6. Vikings would be exposed for weeks, sometimes months. The longest recorded voyage, Norway to Newfoundland, took 3 to 4 weeks of continuous sailing. How did they survive? The answer is a complete system that required reimagining warmth itself. When archaeologists excavated Herjolfsnes in Greenland, they found preserved Viking clothing revealing a sophisticated layered system. Vikings developed different wool grades for specific functions: tightly woven for wind resistance, loose weaves for insulation, and special weaves for moisture management. The critical part, their wool retained 80% of insulating properties even when completely saturated with seawater. Modern fleece becomes useless when wet. But here's the detail that's almost hard to believe. The Laxdala saga describes a daily ritual. Every morning, women crew members would use bone needles and waxed thread to sew men's sleeves shut at the wrists. Not tied, not buttoned, sewn, completely sealed. Before combat or landing, warriors would cut themselves free with their sea axe knives. The next morning, they'd sew them shut again. Why? Because any gap where air could enter or escape compromised the entire system. The layering was sophisticated. Fine weave wool undergarments against skin, medium weight insulation layers, heavy outer tunics, sealskin maritime layers that were naturally waterproof, and fur-lined garments for extreme conditions. Each layer created what researchers call a portable microclimate. Even with seawater constantly spraying, your core stayed warm. But even advanced clothing can't keep you warm during sleep. Your metabolism slows, you generate no heat through activity. In extreme cold, sleep is when people die. Vikings needed another solution. Multiple saga sources describe hudfat, communal sleeping bags made from sheepskin with fur lining, designed for 2 people. One human body produces about 100 watts of heat, but 2 bodies in an insulated space, that's 200 watts in half the volume. The hudfat could maintain internal temperatures 15 to 20 degrees warmer than outside air using only body heat. According to the Landnama book, crews were assigned sleeping partners based on watch schedules. When you came off watch, exhausted and cold, you'd crawl into a sleeping bag your partner had spent 4 hours warming. When your partner came off watch, they'd enter a space you'd warmed. The sleeping area never cooled completely. Ship reconstructions show crews slept between rowing benches on platforms created from stored oars, staying above the coldest bilge air. When storms hit, they'd lower the sail and convert it into a massive tent, trapping warm air from dozens of bodies underneath. Even wealthy jarls shared these arrangements. Survival requirements overrode social distinctions at sea. But maintaining body heat in these conditions required enormous calories, 3,000 to 4,000 per day, from food that couldn't be cooked. Excavations at Hedeby revealed Viking food technology designed specifically for cold consumption. Dried fish, wind-dried cod so desiccated you could use it as building material. Hard rock, but a pound provided 1,500 calories and lasted 6 months. You'd break off pieces and chew, slowly rehydrating it with saliva. Ship's biscuits called nut bread, dense biscuits made from barley flour, nuts, and honey that wouldn't spoil in salt spray and remained edible for a year. And the most ingenious, cold porridge systems. The Icelandica saga describes massive quantities of porridge cooked on shore with added butter and salt, then packed into sealed containers. At sea, it would congeal into nutrient-dense paste you could eat directly or mix with cold water. Excavations at York show the provisioning scale, thousands of pounds of dried fish, hard-tacked biscuits, fermented dairy products, dried meats, nuts, and hard cheeses, all designed for maximum calories with zero cooking. But the food stores reveal something else. Vikings weren't at sea continuously. Recent coastal surveys have uncovered over 200 documented sites, harbor facilities, and supply stations spanning Norway to Newfoundland. The scale became clear with excavations at Torksey, England, 2019 through 2017. What researchers found wasn't a temporary camp. It was a massive operational base spanning 55 hectares, about 100 football fields. The site revealed proper hearth systems, workshops for repairs, family accommodations, storage facilities, training areas, and entertainment spaces. These weren't camps. They were temporary cities supporting entire fleet operations. This is where Vikings did everything they couldn't do at sea: cook hot meals, warm by fires, repair equipment, rest, and prepare for the next journey leg. The strategy becomes clear. Vikings didn't try to survive brutal conditions continuously. They broke journeys into manageable segments. Sail for a week or two, stop at a harbor, recover, resupply, then sail again. Analysis of saga accounts shows Vikings primarily sailed during summer months, late April through early September, when the North Atlantic was most navigable. Winter voyages were rare, only when necessary. The combination of infrastructure, strategic planning, and seasonal timing meant Vikings rarely faced the absolute worst conditions for extended periods. They pushed limits, yes, but within calculated boundaries. But physical systems only work if people maintain the will to use them. Excavations at over 50 Viking camps uncovered more than 300 gaming pieces, dice, carved board games, and entertainment items. According to Oslo's Museum of Cultural History, crews invested significant time in social activities during harsh conditions. This wasn't frivolous, it was survival technology. Games like TAF, dice competitions, and storytelling contests served a crucial purpose. They distracted from discomfort and maintained morale. Modern psychology recognizes psychological thermogenesis, where mental state directly affects cold tolerance and temperature regulation. Vikings understood this intuitively. The sagas describe organized competitions during voyages and are full of humor. There's a passage in Egil's saga where during a brutal storm, a warrior jokes that at least they won't die of boredom. Everyone laughs, tension breaks, they continue. That's not just a story, that's a survival technique. In 2007, experienced sailors and historians built an exact reconstruction of a Skulldalev vessel using authentic materials and techniques. Then, they sailed it from Roskilde to Dublin, across the North Sea. The rules? No modern technology, no heating, only authentic Viking methods. The Sea Stallion voyage, documented by the Viking Ship Museum, confirmed everything. Layered wool clothing worked exactly as evidence suggested. Shared sleeping arrangements were absolutely critical. Daily garment maintenance was necessary. Coordinated watch rotations were essential. Strategic planning mattered more than raw endurance. Crew core body temperatures remained safe. No serious cold injuries. No dangerous hypothermia. One crew member said it perfectly. It's not about being tougher than the cold, it's about being smarter than the cold. Vikings conquered the North Atlantic not despite their lack of shipboard heating, but because they rejected it. This was sophisticated engineering. They made a calculated trade-off, accept controlled discomfort for absolute safety. No fire meant no catastrophic fire risk. It also meant lighter, faster ships that could carry more cargo. Speed was everything. Speed meant successful raids, profitable trade, and survival. Outrun storms, outrun enemies, outrun danger. Every piece of heating equipment they didn't carry was weight for weapons, trade goods, or supplies. Their system, clothing technology, social warming, cold provisions, infrastructure networks, and psychological techniques worked better than heating would have. They reached North America 500 years before Columbus. They established trade routes from Greenland to Constantinople, nearly 4,000 miles. They shaped medieval Europe through 3 centuries of maritime dominance, all in open boats, deliberately choosing to sail without fire. The next time winter wind cuts through your jacket, remember this. Viking sailors chose strategic capability over warmth, operational safety over individual ease, collective survival over personal comfort. They didn't just endure the cold, they systematically transformed their approach to thrive within it. They restructured their social systems around it, They developed technology for it. They reimagined what was possible. Vikings didn't need to heat their ships because they had something better. They had each other. And that cooperation, planning, and strategic brilliance made them unstoppable.